Even though the XSense software is by far the most efficient way to process and analyze the data, it does have its limitations. Due to the single license key, XSense only allows one user at any given time. In addition to that, it also lacks the computational analytical tools to further explore the data. Hence, alternatives were researched and developed to overcome these restrictions. MATLAB is one of the alternate methods that can be used for data extraction. Using a pre-written script, similar graphical outputs to that from XSense can be obtained, as shown here. MATLAB can also be used to plot comparative graphs, unlike XSense, for better visualization. For instance, comparing the flexion or extension of the left and right shoulder, as shown in this graph below. However, it too does have its limitations, with one being the high computing power needed to process the motion capture videos. The software is also not open source and requires a commercial license that could be costly. Another alternative to extract the data is to use Excel. When the XSense video data is imported into Excel, it is represented by an unlabeled spreadsheet where each column is a positional vector angle of a specific joint in one of the three axes of motion, X, Y, and Z. To more easily identify the column representing a specific joint, a variable reference sheet was generated. Using this in conjunction with the time frames obtained for each task during the data analysis phase, we can accurately pinpoint the set of data points corresponding to a certain task. This allows for a more numerical approach, as Excel functions can be used to perform high-level statistical analysis. As an example, the table below represents the joint angle means of various joints for each task obtained using the average function in Excel. A drawback, however, is that it is quite time-consuming, as timeframes need to constantly be updated for each task.